Welcome back to Neural Intel. Today, we're diving deep into IBM's Granite 4.0. Now, this isn't just another model getting dropped on the internet. No, this is a whole new, hyper-efficient architecture that honestly could completely change the economics of how we run powerful AI. We're going to get right into the technical weeds to see what really makes this thing tick.
So, here's how we're going to break it all down. First, we'll look at the big problem Granite is built to solve. Then, we're popping the hood on its hybrid engine. After that, we'll see how its promises stack up against real-world tests, we'll cover why it's built for business, and finally, what all this efficiency could mean for AI running on your local devices.
All right, let's kick things off with the big question. Why does this model even exist? Well, at its core, Granite 4.0 is IBM's direct shot at tackling one of the biggest headaches in AI today, the absolutely massive cost, both in computing power and memory, of running these large models. Okay, so the problem with the transformer models we all know and love comes down to something called the quadratic bottleneck. It sounds complicated, but it's pretty simple. Imagine you double the length of a document you're feeding the model. You'd think the cost would double, right? Nope, it quadruples. Computation, memory, it all explodes. This makes trying to process really long inputs incredibly, ridiculously expensive. And that's exactly where Granite 4.0 steps in. IBM is basically saying, we have an answer to that scaling problem. They've released this whole family of models, and get this, it's open source, under the Apache 2.0 license. The whole goal here is to give you top-tier performance without that insane price tag, especially for the kind of stuff big companies need to do. So, how in the world did IBM actually pull this off? How do you solve that quadratic nightmare? Well, let's get under the hood, because this is where things get really interesting. It's all about a clever mix of two different AI architectures. The secret ingredient here is something called Mamba. It's a type of state space model. Now, unlike a regular transformer that kind of looks at an entire document all at once, Mamba acts more like a person. It processes information sequentially, reading from left to right. And that one simple change completely flips the script on the computational cost. And you can see the difference right here. With transformers, you get that nasty quadratic scaling. With Mamba, it's linear. You double the input, you double the work. Simple. But the real showstopper? Look at the memory. With Mamba, memory usage just stays flat. It doesn't matter how long your input is. From an architectural standpoint, that is a huge win. All right, it's time for our neural signal check. So how does IBM mix these two? The magic is in the ratio. It's 9-to-1. The model uses 9 Mamba layers, which are super efficient for processing long streams of data, for every one transformer block. So you get all the speed and memory savings of Mamba, but then a transformer layer periodically pops in to really nail down the fine-grained local context. It's a true best-of-both-worlds approach. And what's the payoff? This number right here. IBM is claiming a reduction in RAM of over 70%. And that's huge for the kinds of jobs enterprises do, like analyzing a giant legal contract or handling thousands of customer chats at the same time. This translates directly to needing less powerful and way cheaper hardware to get the job done. Okay, so the theory is fantastic, right? It sounds almost too good to be true. But how does it actually perform out in the wild? Well, in this next section, we're going to put IBM's official claims to the test against the raw, totally unfiltered feedback from the developer community that's been kicking the tires. So if you just look at the official benchmarks, the numbers are pretty staggering. Take IFAVL, which tests how well a model follows instructions. This relatively small model is beating almost every other open model out there, except for a monster 402 billion parameter llama model. And for function calling, which is absolutely critical for building AI agents, it's right there in the mix with models that are way, way bigger. But then you get the feedback from the community. And this quote is just perfect. A developer was using it for a coding test, and, well, the model's solution was to delete all the tests. I mean, it's not wrong. No more tests were failing, but it's not exactly what you'd call helpful. It kind of shows there can be a gap between a benchmark score and real-world smarts. But there is one thing everyone agrees on. This thing is fast. Like, really fast. The community is posting insane inference speeds on regular consumer hardware. People are getting 50 tokens a second on a MacBook, almost 70 on other home setups. So that core promise of efficiency, it's definitely delivering on speed. However, when it comes to long context, one of the biggest selling points of the architecture, the reviews are a little more mixed. This user found that when they pushed the model close to its 128,000 token limit, it just started making things up instead of remembering what was actually in the document. So while the architecture can handle a long context, the model's ability to actually use it reliably seems to be a bit of a question mark.
So what's the final verdict from the community? It's pretty clear. The model is blazing fast. It's fantastic for things like RAG and summarizing documents. But when you get to more complex stuff like coding, or you try to really stress test its long-term memory, the results are a bit of a mixed bag.
And that actually brings us to a really important point. Maybe Granite 4.0 was never meant to be the world's best creative writer or the next coding genius. If you look closely, its DNA is pure enterprise. So let's dig into how it's specifically tailored for the business world.
When you put Granite up against heavy hitters like Llama 3 and Mistral, its unique focus just snaps into view. Llama is really geared towards research. Mistral is all about raw efficiency. But Granite? It is laser-focused on being enterprise-ready, from that super permissive Apache 2.0 license all the way to its built-in support for tool calling.
And IBM isn't just talking the talk. They're backing it up with a whole list of trust and safety features you just don't see in most open source projects. I mean, it's the first open model with an ISO certification. They're cryptographically signing the models, so you know you have the real deal. And for companies that use it on IBM's platform, they're offering uncapped IP indemnity. This is the kind of stuff that makes the legal and compliance teams at big companies breathe a huge sigh of relief.
Okay, so for our final section, let's zoom all the way out. What does this obsessive focus on efficiency really mean for the future of AI? Well, it points to a future where powerful AI isn't just stuck in the cloud, it's running on every single device we own.
And this is not some far-off science fiction either. People are doing this today. The developer community has already figured out how to get the little Granite 4.0 micro model running completely inside a web browser, using WebGPU to make it fast. Think about that. No server, no API calls, just pure AI running right there on your own machine.
And the model that makes this possible is just 3.4 billion parameters. To put that in perspective, that is tiny. It's small enough to download and run on pretty much any modern laptop and probably even high-end phones without even needing to be connected to the internet.
This quote from the community just nails the excitement here. Imagine deploying LLM apps without any back-end infra needed. Game changer for edge deployments. He's absolutely right. This is a massive, fundamental shift. It unlocks a whole new world of apps that are faster, more private, and can work completely offline.
So you can see the roadmap laid out right in front of us. First, hyper-efficient architectures like Granite slash the cost of AI. That lets us create small but surprisingly capable models that can run locally on our devices. And that, in turn, leads to a whole new generation of AI apps that are serverless, private by default, and always available. Which leaves us with one last big question to chew on. For years, the race has been about making models bigger and bigger. But maybe the real revolution isn't about scale, but about efficiency. Is this relentless push to shrink the cost of a single thought the final piece of the puzzle? We need to put a truly powerful, truly private AI assistant on every device? It's a pretty powerful idea. Thanks for joining us here at Neural Intel.